Now let's talk about galaxies, starting with the Milky Way. The Milky Way is a spiral galaxy that houses our solar system. The diameter is around 100,000 light years across. A light year, of course, is the distance traveled by light during an entire year of time. Thickness is around 1,000 light years. That would be the thickness like this from top to bottom. Estimated 200 to 400 billion stars. Structure. First you have the bulge, which is the spherical area of all the stars around the center. That would be this area over here, which is around the center, almost spherical. It is at proximity to the center and around it in 3D, so to speak. So it is the thicker region of the entire galaxy. Then you have the disk, which contains the spiral strings made of younger stars, gas and dust. This would be this stretch over here around the bulge. You see this spiral string chains, so to speak, the spiral lines around the center. These constitute together the disk, the galaxy disk, which is this zone colored in gray if you want. Then the halo. The halo is the zone up and below the disk, which is here in this area. Okay, so imagine this is the bulge in the middle and the spiral disk around. The halo is like the 3D covering from top to bottom, almost has a shape of a sphere. It's like a cloud, a spherical cloud of older stars encompassing on the inside the entire galaxy. Okay, so it's made of older stars and globular clusters surrounding the disk from up and below, from above and below. And you have a dark matter halo, which is invisible but adds most of the galaxy's mass. Now, a logical question would be asked, why exactly? Because if you notice, why is the bulge, which is the closest area to the center of the galaxy, made of older stars that surround the center of the galaxy? Meanwhile, for the disk, it contains spiral strings made of younger stars that would be located outwardly much further from the center, and instead of being located in the bulge, they seem to be rotating around the galaxy at higher or longer distances. Okay, so it's made of young stars, gas and dust. So why is that? What's happening here? Let's start with the fact that the older stars would be stars that have had all the reactions, nuclear reactions or nuclear fusion chains exhausted completely, so they become heavier stars. So they contract into more massive stars because the repulsion, which is the outward force caused by the fusion reaction, is no longer taking place. So they collapse, they implode, some of them, and become heavier and heavier. Some, they explode into supernovas. So since they now have become much dense, much massive, and according to the law of gravitational force, okay, discovered by Newton, you know that the force of gravity has to do, or it's directly proportional to the mass, right? F is equal to G, G being the gravitational constant multiplied by m. Lowercase m would be the object surrounding or like rotating around the center of the galaxy. Capital M would be the mass of the galaxy itself, divided by r squared. So when the gravitational force increases, that would be because of the increase of the mass of either the galaxy, which is, you know, the mass of the center of the galaxy is constant, but the mass of the object has increased when it comes to an older star. So due to this fact, the force increases. Now the force is inversely proportional to the distance or the radius of rotation. So since the force increases, then the radius of rotation would decrease. This object would start flying closer to the center. This is what explains the fact that you have older stars at the proximity of the center of the galaxy. So then, why do we, on the other hand, have younger stars, gas and dust, flying within the disk, okay, that are concentrated within the spiral disk around the center or the bulge of the galaxy? This is due to the fact, again, as a conclusion based on the mass and the gravitational force, lower mass objects, okay, so when it comes to heavier objects, they are more close to the center, which forms the bulge. We will explain the bulge later. But for lighter objects like gas, like other materials such as dust, and young stars, since they have a lower mass and since they are rotating around the center of the galaxy, with a lower mass you would have a lower gravitational force in comparison to the centrifugal force that is pushing these objects, these astronomical or astro objects, outward. So this explains why they would be scattered on the disk, meaning they would be at a higher distance from a center, circulating with, lower velocities. They don't need much higher velocity to stay away from the center. But as the object gets heavier, it would be pulled closer to the center. As for the halo, so the halo is this spherical cloud surrounding, okay, so let's say this is the bulge, this is the galaxy disk. The halo would be like the sphere encompassing everything. It is a spherical cloud of older stars. This would be the remnant of the stars, okay? The residues and debris made of also globular clusters surrounding the disk. So it's basically stardust that is very light material surrounding the entire galaxy, okay? So they would be flying around just like the dust flies around easily, because their mass is negligible in respect of the mass of the galaxy, so the gravitational force would be much lower. As for the dark matter halo, it was theoretically proven, okay, so it's invisible but adds most of the galaxy's mass, which explains the gravitational force, being exerted by the galaxy. Apart from the solar system, the sun and its surrounding planets and moons, the Milky Way has other star clusters. Okay, you have nebula, stardust clouds and gas, black holes, neutron stars, and exoplanets. Exoplanets are basically planets that are outside of our solar system. How have we been able to study the Milky Way? Analyzing first radio waves, infrared signals, and other frequencies of the electromagnetic spectrum. This is how you start detecting what lies within the Milky Way, what are the different objects, the rotation speed, other parameters, other constituents or constituting objects of the Milky Way. You have also counting the stars and tracking their motion, okay, using telescopy and astronomical observations, and analyzing through ground and space telescopes like Hubble, James Webb, and others. Going back to an important matter, and this question should be asked actually. Why is there a spherical bulge around the center of the galaxy? Okay, first, stars and nebula with E is plural. In the Milky Way's spiral disk, as to in any spiral galaxy type, orbit the galactic center in relatively regular and circular orbits. Their angular momentum balances the gravitational pull from the center. Okay, so in other words, the centrifugal force is balanced by the gravitational force. This is why you have a circular orbit around the center of the galaxy. So this allows them to maintain stable position or positions at varying distances. These orbits are not strictly mass dependent, rather they are governed by the star's velocities and positions within the galactic potential. In contrast, the stars in the central bulge region, which is this bulge, spherical bulge, in the midst or at the center of the galaxy, follow a more irregular three-dimensional orbits due to the dense and spheroidal distribution of mass. These motions are less rotational or less rotationally organized and result from complex gravitational interactions within the bulge itself, rather than the centrifugal balance, which is centrifugal force versus gravitational force that forms this kind of circular rotation within the galaxy's disk. So the bulge primarily contains older stars and their positions are shaped by the gravitational potential rather than their individual masses. In more simple terms, and this is not to replace the expanded explanation that we've done earlier about the difference between the younger stars rotating around the bulge, the center within the spiral disk, okay, and the older stars that would be more concentrated within the bulge of the galaxy. So, what would be the difference? In a more simplistic way, you see, older stars, since they are heavier, they would have more gravitationally complex dynamics and they would be brought closer collectively to the bulge of the galaxy. All right? But meanwhile, for the younger stars that are lower in mass, lighter, so to speak, they would have a more regular angular velocity, placing them in circular orbits where the centrifugal force is balanced by the gravitational force. So that would be distributed on the galaxy disk rather than on the bulge, where you have a higher center of mass. Going back to the beginning, before a galaxy even forms, you need to start with the raw materials. These are the components that form the gas cloud with its dust in a nebula, which is the birthplace of the first star in the galaxy. Once that star completes its life cycle, either becoming a black dwarf eventually after a white dwarf, or a black hole like the one in the midst of the Milky Way, it will have a powerful gravity that will keep pulling on surrounding gases, dust, and those that are remnant from other dying stars, along with the residues of its own outer layer. As surrounding gases and dust revolving around this black hole clump up, they start forming a protostar and then a main sequence star, which is a more mature star. After the life cycle is finished, this newer star that died will also produce residue expelling its outer layers further from its core, which will participate in creating new stars as well. And this is how the cycle repeats itself as you go further from the galaxy center along the spiral arms, because the closer you get, the older the stars would be. Now this here is even a better perspective than what was explained before. Actually, this makes it even more clear, which is the fact that older dying stars would accumulate in the middle, okay? Meanwhile, the ones that were formed after the shedding of the outer layers, that would be constituting the newer or younger stars. This is what explains why these younger stars would be circulating the spiral disk instead of being accumulated in the bulge, in the central bulge of the galaxy. Another side note to be added is that the final solid material that has been formed through the fusion reaction, such as the iron, I don't know, the plutonium, whatever, like the silicate, these final products that can no longer nuclearly react would form the planets around the star systems. Okay, this is how the planets come to be, from the residues of dying stars. Galaxies and the beginning of the cosmos. So how did the galaxies form and the universe begin? In Genesis 1:1, in the beginning God, or Elohim, created by forming from nothing the heavens and the earth. And here, forming something out of nothing is the word in Hebrew ex nihilo. By the way, which became also the term something out of nothing in later secular science, okay? But except, unlike the belief that everything came out of nothing, I completely believe that there's a catalyst behind all of these reactions, nuclear reactions, all of that matter that came to be. The catalyst is God, okay? Because where did the first form of energy come from anyway? Where had, the first hydrogen atom, the first proton, originate from? So you needed someone who can start the reaction, who can start the first element. More than that, the actual gravitational force has been proven of not being enough to start the reaction. This is why they came up with the theory of the existence of dark matter. So, another important point is that space has a beginning, a starting point that initiated the creation of the time-space fabric, which is denoted in Genesis 1:1, when it says, in the beginning. So there's a beginning for the creation or formation from nothing here of the heavens and the earth, which means the dimensions and the matter, by the way. Yes, it came from nothing, but God alone can create something out of nothing. So the term ex nihilo is correct, but it is God who initiated the process. And every reaction needs a catalyzer or a catalyst. It cannot start on its own. In Hebrews 11:3, AMP or Amplified Version, we understand that the world, universe, and ages, times, were framed and created, formed, put in order, and equipped for their intended purpose by the word of God, so that what is seen, what is visible and tangible, was not made out of things which are visible. Hebrews 11:3. By the world, here the scripture is referring to a multiverse. The second important evidence, and multiverse, I know that it might be controversial, but take it as it is. Multiple universes. We don't completely understand it, but still it's a very large possibility. But the second important evidence is the part stating what is seen was not made of things visible. Now, this has been already proven that physical matter has been created from invisible matter, invisible energy actually, which is the proton, the hydrogen, the energy. And through that energy, these hydrogen particles have fused into nuclear reactions to form different types of matter that we see today as physical and tangible matter. So what is seen was not made of things that are visible, which makes the case for energy and heat transforming into visible matter. That can be also Einstein's theory. It is Einstein's theory seen from this perspective, which is the energy of an object or like generated by a matter is equal to the mass of the matter or the element traveling at square or reacting at square of the speed of light, which is E is equal to mc square, or to be more accurate, delta E is equal to delta mc square, where delta m is called the mass deficit, meaning that the mass that was lost through a reaction at a very high speed, which is the square of the speed of light. Usually this is what happens in nuclear reactions. This mass deficit multiplied by the square of the speed of light would generate the change of energy that we see on the left side of the equation, which is delta E, or the difference of energy between the original energy state and the new energy state after the mass deficit had occurred. The mass deficit meaning that you lost some mass that reacted at high speed as fast as the speed of light. Multiply that mass deficit by the square of the speed of light, you get the energy shift, the energy change. And it's a reversible process, which means that the change of mass can create energy, but also the change of energy can actually lead to a mass creation, a creation of an element, forming of new elements from older elements, which what happens in nuclear reactions, especially fusions, when it comes to the nuclear reactions within the core of a star, which explains how we got different materials today, different types of elements that came purely out of the reaction of protons, of H1, at very high temperatures and very high pressures. As they heated up to like millions of degrees, so these hydrogen elements reacting, they started producing helium, then heavier and heavier elements, all the way to iron, which becomes the core of a final black hole after a supernova. In the verse, the universe and ages, which are encapsulated within the worlds, represent respectively space and time, or space-time fabric. So the physical dimension and the time dimension, also another connotation for that. And it states that they were formed from the Word of God, who is Jesus Christ. Now, the Word also represents sound frequency, vibrations, okay, and sound waves. And it has been proven that every type of matter and every element within this created universe on the periodic table has its own vibrational frequency. Indeed, from a scientific perspective, if we look at how all matter came to be, it started from a raw energy form, and probably the first element that ever existed was hydrogen. We see it in the different reactions, fusion reactions within a star. And due to immense high pressure, hydrogen started heating up. This is due to the gravity, by the way, like culminating and clumping hydrogen elements together under high pressure. It increased the heat, the high temperature, and after it started collecting dust and other surrounding gases, the heat increased enormously until it attained a point where the temperature was so hot and favorable for fusion nuclear reactions. So, hydrogen, due to immense high pressure, hydrogen started heating up until the temperature became so intense, starting a nuclear reaction that led into the formation of different elements, the final form of which is the iron, that is the heaviest and that could no longer react into anything else. Okay, so it can no longer produce anything further. That would be the final state of the reaction. Matter forming from raw energy. Let's go deeper on this topic. So stars generate energy through nuclear fusion. This is the first process, beginning with hydrogen and progressively forming heavier elements. This process, known as stellar nucleosynthesis, is governed by temperature, high pressure, and stellar mass. The fusion chain proceeds until iron has been made, okay, which is Fe56, beyond which the fusion is no longer available. The fusion is no longer energetically favorable. It can no longer be activated. Let's delve into these nuclear reactions. So starting from the hydrogen burning, hydrogen fusion together, H1 with H1, occurs primarily through two mechanisms. You have proton to proton chain, because H1 is actually a proton, the hydrogen atom. Okay, you have low mass stars. This process would be proton to proton change. So P plus P would give us deuterium, which has two protons plus one positron, one charged particle, plus a neutrino. Okay, so now D plus P, which is a deuterium plus proton, would give us He3, helium-3, plus gamma, which is irradiated energy. He3, then that would be, okay, so it is a chain. The third part of this chain sequence would be fusion between two helium-3 atoms, giving helium-4, okay, the same number of mass, and we are left with, because it was 6, okay, we are left with 2 protons, so they are released to the outside. You see the charges should be the same on the left and on the right. We need to always have an equilibrium within the reaction. So the net reaction is 4 protons would give us He4, helium-4 plus 2 positrons plus 2 neutrinos, which is a neutral particle that has no charge, very light, plus a gamma radiation, which is the wavelength, or a photon in other words. Gamma is a photon. Another clarification here, you see the neutron is a particle or an atom that has 2 protons, okay? So in other words, the neutron plus proton, you have 3 positive charges, 3 protons, which give us helium-3 plus gamma. Gamma is the photon released due to the energy of the reaction. For high mass stars, we have what is called CNO cycle, or carbon, azotus, and oxygen. Okay, so at first you have, of course, this would be the continuation of a process that started earlier. Okay, so you add these steps to, or these phases, to the earlier phases we've seen before. So, carbon-12 would react with a proton, producing azotus, N13 plus gamma, plus a photon. Then the azotus would disintegrate into C13 plus positron plus neutrino, positron being positively charged particle. C13 would react plus a proton with a proton to produce N14 plus gamma. N14 with a proton produces oxygen, 15 plus gamma. Gamma again is a photon, a wavelength. Then O15 would decay into or produce into N15 plus positron, positively charged particle, plus neutrino. And N15 with a proton reacting would fuse to produce C12, carbon-12 plus helium-4. Net effect is 4 protons would give helium-4 plus 2 positrons plus 2 neutrino plus gamma, which is a photon. Helium burning triple alpha process. Once hydrogen is depleted, helium fusion begins. So the helium elements would start burning and fusing with other helium atoms. So He4 plus He4 would produce at first beryllium B8. Okay, we're now transitioning into even heavier materials within the core of a star. And the beryllium 8 would react with also the remaining helium atoms, forming C12, carbon-12 plus gamma. Okay, so Be8 plus He4 gives us carbon-12 plus gamma. And you see the mass number here, if you add 8 plus 4 would give us 12. Okay, so it makes so much sense. Additional reaction is C12 plus He4. So 12 plus 4 would give us 16, which is the oxygen plus gamma, or a photon emission. And these gamma elements, or these gamma, not elements, these gamma particles that are being emitted are photonic energy particles that are at the same, actually they have duality. So it is a light wave, it is an energy, light wave, but at the same time a particle. This is what we call a duality of a wavelength and a mass particle within the photon. And this is what produces light coming from the star. That when you look at a star at night, you see it burning. You see the light coming from it. This is due to these nuclear reactions. At higher temperatures, you have C12 merging or fusing with C12, carbon-12, giving us Ne20, okay, which is the neon 20. So what remains is 4, because if we add these two up, you have an element or multiple elements of which the sum of the mass number is 24. Okay, so you have Ne20 plus He4. Ne20 is the neon. This is the type of atom that has 20 as its mass number, and the helium-4, which has 4. Okay, C12 plus C12 also can produce Na23, which is the sodium, plus a proton. So Na23 with a remaining proton, that would be the liberated or free proton circulating here. Okay, so 1 plus 23 gives us 24. Another type of reaction would be one element having 24 as a mass number. That would be the magnesium. Okay, 12 plus 12, 24, plus a photon, a free photon being released. Neon burning. Now, the neon, which has 20 as its mass number, plus 1 gamma, meaning it's fusing with an energy coming from a photon, it would give us O16, which is the oxygen, plus helium-4. 16 plus 4 is 20. But how this Ne had split into these two other elements is due to the fact that it reacted with a photon. Okay? I think here it would be more of a nuclear fission, not fusion. All right? So, also you have Ne20 plus He4, helium and Ne would fuse together to produce magnesium Mg24 plus a photon gamma being released. Oxygen burning. So O16, when it fuses with O16, it can produce silicon Si28 plus He4. So you see 16 plus 16, 32 here, 28 plus 4, 32 as well. Or it can produce P, which is phosphorus, having the mass number 31 plus lowercase p, which is a proton. 31 plus 1 is 32, which is O16 plus O16. So the oxygen atoms are fusing together at this point, at a very, actually much higher temperature, okay? Because the core is heating up even to a higher degree. Then you have O16 plus O16 also producing S32, which is, I think, the silicate, not sure, okay? Plus gamma, which is a photon. And that would be, I think, a final product. It would require much higher temperature to fuse into something heavier. Silicon burning. At extremely high temperatures, a complex network of reactions occur, photodisintegration and alpha capture, like an atom capturing an alpha particle, or photodisintegration, leading into iron group elements, which would be the heaviest elements. So, when you have the silicon merging at a very high temperature, that would require even a much higher temperature than the fusion of helium and hydrogen, of course, because you know the mass number increases, you would require a much higher temperature for the fusion to occur. So silicon, because these are heavier elements, denser elements. Silicon Si28, it will merge or fuse with helium-4, producing S32. Then Ar36, I think this would be silver, then producing Ca, calcium 40, finally leading to the final state of iron, Fe56. Now, as a correction, Ar is actually the argon, not silver. As for Fe, why is it denoted as Fe for iron? Because it is actually a French word, which is fer. Not fair like F-A-I-R, fair F-E-R, okay? This is the word for iron in French. This is why it is denoted as Fe, not IR, for example. To give you an example on how energy is produced in a nuclear reaction such as a fusion. So here you have a deuterium H2 fusing with H1, which is a proton, hydrogen atom. Okay, so H1 plus H2 would produce helium-3 plus a gamma photonic emission. The mass of the proton is given here by 1.00, etc. Mass of the neutron is this one to the right. So MH2 plus H1 is given by MH2 plus MP. So you need to add up M of H2 plus M of a proton. This gives you 3.023217, etc. Now, this is the mass of H2 plus the mass of a proton. The mass of He3, which is produced to the right, so these are the reactants, the mass of the reactants. The mass of the products, you have only one product, which is the helium-3, because the mass of the photon is negligible, very small, okay? Mass of gamma. So MHE3 is equal to 3.016029 U. Atomic unit mass, okay? Delta M, which is the mass deficit or the mass difference between the products and the reactants, is given by 3.023 to 1. You copy it to the T because we need accurate results here. You cannot round it off. We're talking about infinitesimally small particles. Minus 3.0160293 U is equal to 0.00534895 U. This is the mass deficit delta M. So going back to the formula of Einstein, delta E, which is the energy change, is equal to delta M, the mass deficit, times C squared. So the energy released is equal to delta M times C squared. We need to transform it or convert it into mega electrovolt, which is 900. C squared is equal to 931.494 mega electron volts. So E is equal to 0.0053485 atomic mass unit, AMU or U, multiplied by 931.494, which is approximately equal to 4.984 mega electron volts. This is the energy being released from this reaction. Why fusion stops at iron? You see, iron has the highest binding energy per nucleon. Fusion beyond iron would require energy, would absorb energy instead of releasing it. Why? Because the energy value per mass number is maximized near Fe56. Okay? So thus, fusion up to iron releases energy. Meanwhile, this energy release is no longer possible after the iron is formed or has been formed. Why? Because fusion in such case would absorb energy, would consume energy when it arrives to the iron level. This is why mainly the iron could no longer fuse or react to form another metal or another heavier element after this point. Here, a clarification I should have made before. Okay, when we talk about the number of protons within an element, we are referring to the atomic number, not the mass number. The mass number is actually the number of protons plus the number of neutrons within the nucleus, so as to make this difference. Okay, so we have the atomic number, which is the number of protons, and the mass number, which is protons plus neutrons. And here it's talking about the mass number, EB over A, is maximized near Fe56. So we're talking about a very heavy element that can no longer release energy, but it consumes or absorbs energy after the iron has formed. The final stage, once the stellar core becomes iron, at first the fusion reaction ceases. As a consequence for that, and even before it ceases completely, as it recedes, the outward force, outward reaction, okay, the outward pull that was being generated by the fusion process, that was counterbalancing against the gravity pull caused by the mass of the star, this becomes weakened, so the gravity force would take over. It becomes much powerful, causing the collapse of the core under heavy gravity. This will cause even much higher pressures and a more heated core. Okay, a rise of the temperature within the core, which will eventually lead to a massive or an enormous explosion called the supernova, especially in massive stars with a very high mass. Stars, as a consequence, act as a cosmic furnace, okay, transforming hydrogen into heavier elements gradually through successive fusion stages. This chain progresses from hydrogen to helium, then to carbon, oxygen, and eventually iron, making the end of energy producing fusion in stellar cores. And for supernovas, they eventually end up in a black hole for massive stars. Let all the earth fear and worship the Lord. Let all the inhabitants of the world stand in awe of him. For he spoke, and it was done. He commanded, and it stood fast. Psalm 33, verses 9 and 8, or 8 to 9. Another verse here is showing us that everything created, whether galaxies, stars, planets, moons, were created by spoken word from God. And Jesus is the word, but also this can mean sound frequency. It means both. So it has a power of a frequency that dictated the physical laws of the universe and everything in it. Because when he says that, the Bible says that God took a scroll and stretched it upon the firmament. By the way, this is also the thermodynamic expansion of the universe, and a scroll has words in it. So it is like the physical laws of this universe. It is God who sits above the circle or the horizon of the earth, and its inhabitants are like grasshoppers. It is he who stretches out the heavens, you see the stretching, like gauze, curtains, tent or thin clothes, so it is a fabric, alluding also to the time-space fabric, and spreads them out or stretches them out like a tent to dwell in. Isaiah 40:22. Another word for tent would be also a canopy. That's interesting. He who stretches out the heavens. Heavens refer to multiple dimensions. The act of stretching out is what was discovered by the Hubble Space Telescope on the thermodynamic expansion of the universe, which stretches out uniformly like a garment or an elastic clothing. So let's say you have a sweatshirt, for example, or a t-shirt, and you have different or multicolored dots on that t-shirt, sprinkled, okay? Now, if you stretch the t-shirt in one direction by, for example, 2 centimeters, this 2 centimeter gap would be added to the distance between any two consecutive multicolored dots in the same direction of the stretching. So let's say you have two dots that were distant of 1 centimeter, they become distant of 3 centimeters. Another two dots in the same direction, they had a gap of, let's say, half of a centimeter, so it becomes, let's say, 3.5 centimeter if the stretching was 3 centimeters. Was it 2? I think it was 2, I don't remember. But the point is, the same gap is introduced between any two consecutive dots. The dots here, of course, represent the stars within or on the same direction of the stretching or the expansion. So it's not only the edges, it's the entire fabric will stretch in a constant manner. This is what is called the Hubble constant. And this is the fact that about thermodynamic stretching or expansion of the universe, which was mentioned, interestingly enough, in the Bible in multiple places. It's not only Isaiah 40:22 about the stretching. And like a garment is a fabric also, just like the time-space fabric, which is interwoven together and goes like a texture together. So once it is expanded or stretched in one direction, it stretches all together, just like when you stretch a garment, which, by the way, can also be influenced or caused by the effect of gravity, okay, of a traveling black hole near or through that type of garments. So here it is mentioned again. If you imagine a shirt with multicolored dots painted on it, if you stretch it by 5 centimeters, let's say, you will notice that in the direction of the stretching, the gap between two respective dots will increase by 5 centimeters along the entire cloth in the same direction of stretching, which became known as Hubble's law. Formation dynamics of the universe. Actually, it's better to call it cosmos, which means that it was created. It does not come on its own. So, in secular science, they believe that everything in the universe started from a singularity, a point just like what you end up with when you have a black hole after a supernova. Okay? A singularity which was highly dense point, just like the final phase of a supernova. That point had infinite density. It then exploded into what is known the Big Bang, releasing an enormous amount of energy and heat with dense plasma. The denser regions started attracting more matter through gravity, becoming the birthplace or bursting place of stars. So it formed a nebula around it after the explosion, and this bursting place of stars also created galaxies as well. Now, my own belief is that according to the book of Genesis, God in the beginning created heaven and earth, so he created dimensions and matter. So this matter started condensing together, which led to the first star, and that star, after the explosion, became a singularity, then it exploded, forming the nebula, and this is what started other reactions to create other galaxies and whatever else that we see. Okay? But now, on another hand, when we talk about the intelligent life, this would be another subject because intelligent life has a code to it. Code cannot be random. Like if you're a software engineer or something like that, you can never write a code to a program randomly that it would work out. No way. It needs a collaboration of multiple people at times, and at one error, the software won't work. Okay? So that is left apart, especially that after they had discovered the DNA within organisms, it's no longer viable, it's no longer valid to say that all of these, animals came in a random act. Dark matter, believed to be an invisible and dominant component of matter, started assembling under gravity. These bundles of dark matter became the gravitational wells. You see, because the gravitational pull of the matter itself was not powerful enough in order to assemble hydrogen and dust particles to, heat them up under a very high pressure, causing a high elevation of temperature that would lead eventually into a fusion reaction, starting a protostar. It was never enough. This is what explains the need for a higher gravitational energy or force, which is from another actor, that would be the dark matter, heaping up the matter under it within this gravitational well under higher gravitational force, higher pressure, that would lead to, again, a rise in temperature, eventually causing the fusion reaction to start within a protostar. Hydrogen and helium, that were the main elements created during what is called the Big Bang. Actually, I believe that they pre-existed before, okay? In a form of energy, perhaps, raw energy. Actually, perhaps the H1 is the first element that ever existed, which is the proton. So, they began falling into these gravitational wells called halos. As these gases cooled down, they started contracting and fragmenting, fusing into the first protostars, which of course eventually became the main sequence stars. So let's talk a little bit about dark matter and dark energy and how we came to realize that there was dark matter in the universe. At first, we have the evidence of missing mass. So the first clue was through galaxy rotation. In a stable circular orbit, the centripetal acceleration of a star is provided by the gravitational pull of the enclosed mass. Okay? MR. The orbital velocity v is given by Vr is equal to the square root of gmr divided by r. Gm of r. So m is a function of the radius divided by r. According to the light distribution, m of r should plateau beyond the galactic bulge of the galaxy, leading to a Keplerian decline where v becomes proportional to r to the power minus 1/2. However, observed rotation curves show that v of r is a constant approximately. So m of r is directly proportional to the radius. This suggests that galaxies are embedded in a massive dark matter halo that's keeping, the entire velocity together and constant, that does not emit light. To further explain the discrepancy, what is supposed to happen is that as the star moves away from the galaxy bulge where the mass is concentrated, it should be rotating at slower speeds, okay? Which is proportional to 1 over square root of r, according to Keplerian physics, right? Because as you move further from the center, the object should be rotating slower, requiring less centrifugal force, okay, and due to the fact that you have less gravitational pull against it as it goes further away from the center. But this is not the case. It's not what's happening. Instead, the mass remains proportional to the radius, and Vr, the velocity, remains constant. So this is what indicated the existence of a dark matter halo that does not emit light. Fritz Zwicky and galaxy clusters. Fritz Zwicky utilized the Vireo theorem to study the dynamics of galaxy clusters. For a system in equilibrium, 2t plus v, these are vectors by the way, is equal to 0. So m Vireo, mass Vireo, is approximately equal to r sigma squared divided by g, where sigma is the velocity dispersion, r is the cluster scale. Okay, Zwicky discovered, and g of course is the gravitational constant. Zwicky discovered that the observed mass based on luminosity was insufficient. You see, he saw the inconsistency, so it was insufficient to prevent galaxies from flying apart. There should have existed more mass to guarantee a gravity strong enough to pull the matter together and everything within the galaxy to be kept, preventing it to fly or from flying apart due to the rotational motion around the center. So this led him to propose the existence of dark matter. Another evidence for dark matter is the rotation curves. So observed rotation curves of spiral galaxies remain flat at large radii, where Vr, velocity, is approximately constant. So it is restating what we've spoken before. For this to occur, the total mass mr must increase linearly with r, with the radius, the distance from the center, implying the existence of a dark halo matter, okay, or dark matter halo. Otherwise, the velocity of rotation should be slower as you move away from the center, according to Kepler's law. So V of r is equal to the square root of gmr divided by r. If v is constant, then m of r is proportional to the radius in such case. Gravitational lensing. You see, massive objects act as gravitational lenses by bending the light into themselves, not necessarily completely swallowing the light, but changing the direction of the light due to extreme gravitational forces. So they bend the path of light from background sources. The Einstein deflection angle alpha is given by alpha is equal to 4gm, m being the mass, divided by c squared b, where m is the lens mass, c the speed of light, b is the impact parameter, This allows scientists, of course, G is the gravitational constant. This allows scientists to map invisible matter by observing the distortion of light and the distortion of the imprint of distant galaxies being received by a telescope. So they would appear contorted and distorted. That would give you a clear idea that there has been a light bending due to gravitational forces incurred by invisible matter, which would be the dark matter. The bullet cluster. The collision of two galaxy clusters, what is called the bullet cluster, provided empirical proof that mass can be separated from visible matter. So while the X-ray emitting gas, which is baryonic matter, physical matter, was slowed by ram pressure caused by the impact, the center of total mass of the entire galaxy, of each galaxy detected via lensing, moved ahead unimpeded, without deceleration, without being flustered, so to speak, which demonstrated that dark matter is weakly interacting with this impact, or it is collisionless. CMB, or cosmic microwave background. So, as we mentioned, according to the law of the thermodynamic expansion of the universe due to the redshifting, for distant galaxies you would start detecting, due to the redshift, a longer wave that would be the red waves. But as different galaxies from the early universe move further, this wave falls below the visible range into infrared, then into radio waves. That would be the cue or token or evidence for a much earlier universe and galaxies that had moved way further, to the point that the waves being received have fallen all the way to the level or the range of radio waves. Okay? So, analysis of the CMB anisotropies provides a snapshot of the early universe. The relative heights of the acoustic peaks in the temperature power spectrum constrain the cosmic energy budget. In other words, as we measure the remaining energy and the acoustic peaks, which are like the evidence of the matter existing in the universe that had been left from the creation stages of everything that we see, they don't add up with only the physical matter. So for baryonic matter, physical matter, it's approximately only 5% of the consisting mass that is measured. For 27% remaining, you have dark matter, and 68% that would be the dark energy for the universe to be at equilibrium, so to speak. Let's talk about different candidates that can be suitable to be defined or designated as dark matter. You have WIMPs, or weakly interacting massive particles. WIMPs are heavy particles that interact via the weak force and gravity. The WIMP miracle, as referred to the fact, it refers to the fact that particles with weak scale interactions naturally produce the observed Rayleigh density, okay, which is omega P h square is approximately equal to 3 times 10 to the power minus 27 centimeter cubed s minus 1 over sigma v, where sigma v is the thermally averaged annihilation cross section. Another potential candidate is the axions. Axions are ultralight particles, approximately 10 to the power minus 6 to 10 to the power minus 3 electron volts, proposed to solve the strong CP problem in QCD. Okay? Their mass MA is related to the Petchy-Quinn scale, Fa by Ma. The mass is approximately 0.6 mega electron volts times 10 to the power of 10 giga electron volt divided by Fa, which is the frequency. Okay? Axions are considered a prime candidate for cold dark matter despite their low mass. Machos, or massive compact halo objects. Machos are compact objects such as black holes or brown dwarfs detected through microlensing. The magnification A of a background star's light during a microlensing event is AU is equal to U squared plus 2 divided by U square root of U squared plus 4, where U is the impact parameter. Observational constraints indicate math shows cannot account for the majority of dark matter mass. Some other exotic ideas, you have sterile neutrinos, right-handed neutrinos that interact only through gravity and mixing with standard model neutrinos, and primordial black holes or PBHs. Black holes formed in the early universe. Unlike stellar black holes, PBHs are non-baryonic candidates, so not formed of physical matter. It formed before Big Bang nucleosynthesis. Detection methods, you have first direct detection. Direct detection experiments search for nuclear recoils produced by the scattering of WIMPs, WIMP particles, off-target nuclei in ultra-pure underground detectors, such as in CERN. The differential event rate dr over der is expressed as dr over der equal rho 0 divided by m key mn integral v min to infinity vfv d sigma dv over der. So the change of sigma, okay, in respect of the energy, where rho 0 is the local dark matter density, that's the density of the dark matter, Mn is the target nucleus mass, okay, target nucleus mass, and Fv is the velocity distribution. As a reminder, sigma times v is the annihilation cross-section. Here we have the derivative of sigma times the derivative of v. So it is the differential of that annihilation cross-section. Indirect detection. This method seeks the stable products of dark matter annihilation, such as photons, gamma, neutrinos, nu, or antimatter, okay, occurring in high-density regions. The expected flux phi is given by phi of delta psi or psi, which is, by the way, the change of the wave or the variation of the particle wave, energy wave, is equal to sigma v, which is the annihilation cross-section, divided by 8 pi m square key, that is the mass, integral delta psi integral LOS rho square L dl d gamma, and rho square rho would be the density parameter. The term in parentheses is known as the J factor, characterizing the dark matter distribution, density distribution in the observed region. Particle accelerators such as LHC in CERN, Large Hadronic Collider. So in high energy colliders like the LHC, dark matter may be produced in proton-proton collisions. Because dark matter escapes the detector without interaction, it is identified via missing energy, missing transverse energy, so which is given by E miss equal to minus an absolute value sigma PTI, where PTI represents the transverse momentum of all detected visible particles. A significant momentum imbalance would indicate the existence and the energy of the dark matter that has been scattered. Okay, it indicates the production of non-interacting particles, of which you can identify the dark matter, or said simply, yeah, straightforward, what can be called as dark matter. Dark matter in cosmology. Structure formation. Dark matter is the primary driver of structure formation. In the early universe, density perturbations, delta is equal to rho minus rho bar divided by rho bar, grew via gravitational instability. In an expanding universe, the evolution of these perturbations in the linear regime follows second partial derivative of delta in respect of time plus 2h partial derivative of delta in respect of time over dt is equal to 4 pi g rho bar m delta. So baryonic matter later collapsed into the gravitational potential wells created by these dark matter halos to form galaxies. To make it a little bit more simpler, the partial derivative of delta in respect of time, second partial derivative, is actually the rate of change of the perturbation, which is the density change actually, okay, in respect of time. So the second derivative would give you the inflection or the concavity. How severe is this change of density, so to speak, plus 2h partial delta over partial t, 2h, h being the Hubble constant. This change of density perturbation gives us the gravitational instability, okay, within the field. So you have 4 pi, this is equal to 4 pi g times rho bar m, that would be the changed value of density, multiplied by delta, which is the perturbation factor, which again leads us into the fact that later in the universe, the baryonic matter collapsed into gravitational potential wells that contributed into the creation of galaxies. These are called the dark matter halos. Large-scale structure, the distribution of matter in the universe forms a cosmic web. This is quantified by the matter power spectrum, or pK, which represents the variance or variance of density fluctuations at a given scale k. So pK is proportional to k, the scale, to the power of n, times t squared k, where tk is the transfer function. The observed suppression of power at small scales confirms that dark matter is called dark matter, or CDM, consisting of slow-moving particles that allow for bottom-up structure formation. Finally, universe composition. The global geometry and content of the universe are defined by the Friedmann equation. The current energy density parameters omega I is equal to rho I over rho C, which is approximately, okay, for normal baryonic matter, omega B is approximately 0.049, dark matter, omega C approximately 0.268, dark energy is approximately 0.683. The total density, omega total, is equal to sigma omega I, approximately 1.0, indicating a flat universe where dark matter outweighs visible matter by a ratio roughly of 5 to 1, which is, by the way, what we observationally see. Formation dynamics, biblical perspective. So let's look from the lens of the Word of God into how everything came to exist within the universe. And God said, "Let there be light," and there was light. Genesis 1:3, Amplified Version. So God spoke. Here you have a frequency, a word spoken, and this frequency triggered the creation of light. By the way, which is in the realm of physics possible, because this is how light can be generated from matter. You see, when you trigger an atom through a high frequency, you start vibrating the electrons, they would get excited, accumulating more energy, so they would translate from a lower energy band into a higher one. Now, once they fall back into the ground state, then they would release a photon, which would be the light wave. So God spoke light into existence. Technically speaking, God, through sound frequencies, sound energetic waves, created light. And God made the expanse of sky and separated the waters which were under the expanse from the waters which were above the expanse. And it was so, just as he commanded. God called the expanse of sky heaven. Genesis 1:7-8, Amplified Version as well. So the earth's substance for dust and other particles were already created, and they were afterwards covered entirely by water. Then God spoke, and there was a separation of waters above and below the sky. This one is interesting also. Then God said, "Let the waters below the heavens be gathered into one place of standing or pooling together, and let the dry land appear." Genesis 1:9. Water receded in one place, and dry land appeared on earth. And God said, "Let there be light," and there was light, Genesis 1:3. So God spoke light into existence. Technically speaking, God, through sound frequencies, sound energetic waves, created light. Then he, everything was covered with water, and the water then receded. Now, this is my own speculation because it talks about water above and below heaven, and then when the water receded, then the dry land had appeared. So I completely believe that everything started in a fluid, liquid state, then it became solidified after a specific time, as the universe cooled down. This is what formed the dry land, and also apparently what remained are liquids, among which the fluid water. So the dry land and anything solid had come out of a liquid state and solidified. So God said, "Let the earth sprout tender vegetation, plants, yielding seed, and the fruit trees bearing fruit according to, limited to, and consistent with their own kind." So they don't reproduce according to another kind. They don't produce hybrid species, whose seed is in them upon the earth. And it was so. Genesis 1:11. The first forms of primordial life, of seeds and vegetation appeared at that point, but the stars were not yet even created here. Now this might be controversial, because if we're gonna take that in a chronological manner, stars were not yet created. In verse 14 it says, "Then God said, let there be light bearers, sun, moon, stars in the expanse of the heavens to separate the day from the night, and let them be useful for signs, tokens of God's provident care, and for marking seasons, days, and years." Because we measure seasons, days, and years according to the moon and the sun. Genesis 1:14. At this stage, the sun, moon, and stars were created, and in the part where it said, "Let them be useful as tokens for seasons, days, and years," indeed time has been measured according to the revolution of the sun and the moon. But more than that, even star constellations in antiquity were used as markers of times and seasons, given that specific constellations will line up above a particular geolocation on Earth every n,000 years. Verse 21, God created the great sea monsters and every living creature that moves, with which the waters swarmed according to their kind, and every winged bird according to its kind. Genesis 1:21. After the creation of moons and stars, the fish and other life forms that move within the water were created, along with the birds. It's interesting now that he's referring to sea monsters in general, and it's not just whales, but even water dinosaurs such as Cryptoglidus, Elasmosaurus, and what became modernly referred to as the monster of Loch Ness. In the same category, you have the monster in the book of Job called Leviathan. Leviathan was described by God in front of Job in details as to its scales, its size, how it cannot be captured by a whale, by an ordinary fisherman. It cannot be harnessed. Its power is so gigantic, that only God can take over it and subdue it. So Leviathan was one of these sea monsters that were enormous in size, and you would think that it's like a mythical creature. It's not, because it's mentioned and described in details in the book of Job. Verse 24, then God said, "Let the earth bring forth living creatures according to, limited to, consistent with their kind, livestock, crawling things, and wild animals of the earth according to their kinds." And it was so, because he had spoken them into creation. Genesis 1:24. Now, at this phase of creation, animal life on earth comes forth after earth became ready with vegetation and seed required to sustain them, which makes sense. It's interesting that the verse keeps repeating the verbiage "limited to, consistent with their kind." The reason for that is, unlike the mainstream idea of different life forms evolving from one another or from one cell, by design each species reproduces after its own kind. So dogs give birth to other dogs, cats to other cats. Now, you would ask, how do you explain 100 types of dogs or frogs? Where did that diversity come from? The thing is, different diversities, different types of multicolored frogs, different types of birds of the same kind, okay? They come from the very same prototype, within which all of the DNA information that are required or necessary for diversity, like diverse hair colors for humans, okay? They were carried in the same prototype in the first human, all of these colors. But the mixture of these colors would show up, okay, would give us a new version, a new hair color in one generation. And you have, by the way, recessive genes and dominant genes. In other words, when you might carry red color within your genes, within your genotype, without being apparent in the phenotype. Phenotype is the DNA traits that actually become physical traits that take over physical appearance. So you might carry different type of information within your DNA, but it does not mean necessarily that it would show up in the physical traits. It remains recessive or dormant, okay, without being explicitly, verbiated in the outer appearance. For example, you might have the blonde hair color trait within your genotype, but it's recessive, so it remains dormant and hidden within your DNA until it meets another recessive crossing. So in the next generation, you would have children that can possibly get, the blonde hair type, in case the other person also has it within him. So you have dominant versus recessive genetic traits. This is what explains why you would have people that after some generations would show up with a different diverse hair color or eye color. It was always within the DNA sequence, but it was dormant. Frogs, for example, also have diverse sizes, varied shapes, different skin pigmentation. Some are poisonous, others are not, but the DNA sequences were already available in the first parent, in the first frog. And these would start mixing up with other, frogs to produce different diverse types, diverse species. Okay, so these traits are expressed, others remain genetically recessive or hidden. Again, to put it in a quite simple manner, most of us have the gene code for blonde hair, for example, but for many it remains recessive, okay? Meaning that since it's a recessive, weak physical trait, it needs another recessive allele or chromosome brand to produce in a generation a child with a blonde hair. Otherwise, it can be dominated by black hair, so it becomes or it remains hidden. So despite the fact that it's carried in the genotype within the code sequence, it doesn't show up as a physical trait and remains concealed within our DNA code sequence. But in later generations, it would likely show up in one of the children when two recessive brands meet together, so this is when it becomes physically apparent, just like being also left-handed. This would be another recessive trait. Now, pardon me for carrying a little bit longer on the DNA subject, despite the fact that it wasn't a part of the main presentation, which is about astronomy, okay? But one final note before ending on this part. You see, people have wondered for years how come Noah had all these types of animals, okay, fitting on the ark, okay? There was no way for such diversity to fit on the ark for Noah to carry them to safety, for them to be reproducing after the flood had ended. The thing is, you see, the fact is, all of these diverse creatures, all of these diverse animals came from one parent that had all the DNA information required to reproduce different types of dogs, different types of cats, different types of even the humans themselves, okay? The people that were on the ark were able to produce a diverse large family on the earth coming from different, having different races, different ethnicities, different hair color, skin color, etc. So it's possible because all the genetic information required to get this diversity was already built in to the genome. So let's back up a little bit. The space-time fabric and dimensions were created first. Then after it, the original substance of matter like dust particles and water. Then light was spoken into existence by God. In other words, through frequency and vibration, light came to existence, which is another word for energy and radiation, because light is an energy wave, electromagnetic wave. And through it, matter was being transformed, conforming to Einstein's theory of E is equal to mc squared, stating that energy can transform into matter and vice versa. Now, gravitational forces started acting between different particles and gases, leading them to condense together, with the assistance, I should say, of the gravitational wells of dark matter that reinforced the increase of pressure and leading to an increase of temperature and heat, causing the fusion reaction to start the first protostar. Hydrogen and helium assembled together, and as the gravitational forces increased, the assembled core heated up, eventually leading to the fusion process to form stars. Actually, I believe that there was only hydrogen, which formed in its turn helium, and the sequential different fusion reactions that took place afterwards. Massive superstars that exploded in the latter phase of their life cycle each led to a black hole, attracting to it other stars and stellar objects. Some sucked into its core, others circulate around it, leading to the formation of spiral galaxies. And also, the remnant of the explosion of these stars created the dust and gases that formed the nebula, which became the birthing places of new stars. As for the planetary systems forming around stars like the solar system, the matter circulating fast enough around the central star, which is the sun in our case, and the solar system it managed to escape being swallowed in and started piling up into more condensed composite. Now, the heavier materials made of metals and dust and silicate, which is the rock substance, rotate closer to the central star. Having a greater mass, they become subject to a greater gravitational force pulling closer to the star. This is due to the gravitational force formula F equals gmm over r squared. R is the radius of rotation. As they pile up together, they become even heavier, attracting more materials such as dust and some gases, forming heavy and extremely hot planets, such as Mercury and Mars, due to their proximity to the star. Also, I should add that materials such as iron and silicate actually originated from a former supernova, where the explosion of a star at a latter phase shed out its external atmosphere that's formed of rocks, of gases, and of iron, and after the explosion, the things that escaped the gravity of the black hole that were shed, like these types of elements that were shed on the outward of the receding, even before actually the supernova, the material that were shed outwardly as the core of the star receded, plus after the supernova, the explosion sheds out heavy elements such as iron and such. These can no longer react in order to form or to participate in the fusion of a new star, a creation of a new star. These clump up together to form planets. Now, the heavier ones would be the closer or the closest to the star of the system, and the lighter ones would form gaseous planets such as Venus and Uranus. These would be lighter and further from the sun, with a thicker atmosphere and even, a larger volume because the gravity is lower. They are formed more of gas and silicate. Meanwhile, the ones that are close to the sun, for example, such as Mercury, have more hotter core that is much heavier, more iron-based, more silicate, lesser amount of silicate, but much lesser gases, if there are gases at all, okay? Because the gas would evaporate to the outer atmosphere, and these would be the lighter materials rotating much further from the center, which is the central star. So the lighter materials, made mainly of water, gases, and some dust particles, will be less subject to the forces of gravity, making their centrifugal force overcoming and more dominant over the gravitational pull. And here's why. If we go back to the gravitational force formula, F is equal to G being the gravitational constant, of course, times m over r squared. Lowercase m is the mass of the object rotating around the sun, and capital M is the mass of the sun itself, okay? Divided by r squared. You see, when m is very small, very tiny, the gravitational force would become so negligible. It would still persist, but it will become much lower than the gravitational force by which a heavier object would be pulled. So this will make the gravitational pull much weaker than the centrifugal force caused by the motion around the star. This will allow these particles and gases and dust to rotate around the star at a further distance with a lower speed required, without being sucked. Gradually, due to their gravitational forces, they start piling up, forming mainly gas-made planets. Most gas composites will freeze as they gather under pressure, and since they are, by the way, located at a longer distance from the sun, so they would be freezing, mainly due to their far distance from the sun. Also, another component would be gathered with them, which is the silicate, the rock material. As their assembled weight become heavier, they attract heavier objects like dust and rocks and maybe some small concentration of metals. Let's talk about the types of galaxies. So what are the most known and common types? You have the spiral galaxies, like the Milky Way, which contains older stars around the center, which were the building blocks or the foundation of the galaxy itself. Younger stars that are hot blue in the arms, in the spiral arms within the disk of the galaxy, and stars in formation process in gas and dust-rich regions around the halo. Now, for older stars, they would be within the bulge or the center of the galaxy, known as the bulge, which is like a spherical concentration of older stars. Meanwhile, the disk would be like this. So it's like almost a Mexican head. It looks like that. The bulge is spherical, meanwhile, the galaxy disk is like that, elongated around the center. Barred spiral galaxies, similar to spiral galaxies, but have an elongated bar shape extending from the bulge. It's not circular, so to speak. And gas are funneled through the bar, possibly triggering star formation as well. Elliptical galaxies, nearly spherical E0 or tightly elongated E7, like an ellipse. So instead of a circular disk, it would be an ellipsoidal disk around the bulge, mostly made of old stars like red stars. Stars move in random orbits, range from dwarf ellipticals to giant ellipticals. You have lenticular galaxies S0, hybrid between spiral and elliptical, appear often as faded spirals, having used up their gases. That's why they lose their uniform disk shape, correct? And irregular galaxies, so these would not have a defined shape, and these are mainly made of remnant of gas, dust, and young stars, so dying stars, and young stars that are being formed, usually resulting from galactic collisions. Another thing I want to add about lenticular galaxies and why they are named this way, you see, the word stems from lens. It's like a lens, okay? A transparent glass lens. It is due to the fact that most of the gas has been used up, so they appear as faded spirals that are transparent, have a transparent shape, because most of the gas has been used up and exhausted. This is why they appear the way they do. Galaxies having a high density of gases, dust, and other materials are more likely to be spiral galaxies, in case they have older stars that gather within the bulge region at the center and enough material to form younger stars that would be located in the spiral disk, okay, from the remnant of dead stars and ambient materials as we move further from the center. As more stars and gases are funneled through, they become elongated, forming the bar-shaped spiral galaxies, while star formation frequency remains high. When gas and dust start getting exhausted, fewer stars are formed, and most remaining stars will be mostly old, gathering in the bulge area. Stars will move in a random orbit, and the galaxy shape becomes elliptical or elongated. As the concentration in gas and dust gets depleted or gets even lower, the star formation will decrease even more and the galaxy becomes disc-shaped. For the last type of galaxies, which is the irregular, there's no defined shape for it, and it has younger stars in large that started forming due to the galaxy attracting gases and other particles released from recent supernovas nearby. The gravitational forces still weak to form a definitive shape for the galaxy.